Okay, hello, this is Connor Bosch. So here I have my DC motor switch direction circuit on TinkerCAD here. So first things first, I'm going to start off with the H bridge here. I have the H bridge connected into the middle of the breadboard. I'm going to start on with pin 1, which is the enable pin. It's going to be connected to the 3.3 volt bus. I'm going to have pin 2 here connected to pin D4 on the Arduino Uno. I have the output pin connected to this motor, and then I don't have the ground connected on this side. I have the other side of the motor connected straight to this output pin, and then I have input pin 2 set to pin D5, and now I have the VS pin connected straight up to the VCC pin on the 9th pin of the H bridge, and then that's connected straight up to the 5 volts bus. Input 4 pin here is connected up to D2 here on the Arduino Uno. I have my motor pin connected to the output. I have the ground connected on this side, so I only have one side of the H bridge connected to ground. I have the other side of the motor connected to the other output pin, and then I have the last input pin connected to D3. So yeah, I have the 5 volt bus up here, and I have the 3.3 volts bus here, which is coming straight from the Arduino. And I have my 2 ground pins here. So I'm going to start simulation here. What's supposed to happen is each motor is supposed to drive in one direction, and then after a few seconds it's going to go in the opposite direction. So as you can see here, it's 9,000 RPM, straight down to minus 9,000 RPM, back up to 9,000 RPM, and then same down here, 9,000 RPM, and then straight to minus 9,000 RPM. So I'm going to look in the code here, show you what's happening. So I have defined all my pins. This is going to allow me to transfer straight up to Arduino NANO when I'm building the physical circuit. I have in my void setup here, I have pin mode to motor A's. I have the pin mode to the motor A, the first wire, which is this one, and then the second one. So motor A1, motor A2, and then same thing motor B1, so this wire, and then motor B2, and they are all set as outputs using the pin mode function. Now in the void loop, this is what's going on. So I have these 4 functions here, which is the digital write function, which is going to be set a 1 or a 0. So it's going to set a high or a low value to each motor. So I have, as you can see, I have motor A1 set as a high, and a motor A2 is set as a low. This will allow the direction to go in just one direction at a time. If I was to, see, I'll show you here. So if I was to set the motor A1 and 2 as a high, they'll both cancel out, and you'll see it's going to go straight to 0 RPM. So that's low. So I have motor A1 set as high, motor A2 set as low, so that's going to turn in one direction. Same thing with motor B. I have a change high and low, so it's going to go in just one direction. Then I have a delay here, which is 3 seconds delay. That's going to allow this loop to go ahead, so each motor is going to spin in one way, in one direction. Then it's going to do that for 3 seconds, and then it's going to go next to this one, which is going to be the complete opposite as these 4 functions here. So as you can see, motor A1 is low now. Last time it was high. Motor A2 is high, and last time it was low. So it's all just backwards here. So what's going to happen? It's going to go through this loop. It's going to go in one direction. It's going to delay that for 3 seconds. So it's going to be going one direction for 3 seconds. And once that 3 seconds is up, it's going to go straight to this function. And it's going to go in the opposite direction for another 3 seconds. So I'll show this again with side by side with the code. So as you can see, 9,000 RPM minus 9,000 RPM. So if I was to connect this to a 2 motors on a robot of some sort, mini robot or a car, it's going to go forward 3 seconds and then backwards for 3 seconds. Thank you.